Welcome to my channel, Converting Decimal Numbers to Binary Numbers. My name is Ayaba Christopher. Decimal means base 10 and binary means base 2, and base 2 means all numbers that are less than 2. In fact, positive numbers, and all positive numbers that are less than 10 are called binary numbers. So as we stated earlier, decimal means base 10. And if you look at it, you realize that the set of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all decimal numbers because they are less than 10. And if you also have numbers like 25, 30, 26, 47, 107, they are also called decimal numbers. And the reason behind that is they are considering the individual figures in the number 25 or 30 or 26, 47, or 107 or any number, and you realize that when you take the individual figures, 2 is less than 10, 5 is less than 10, and if you take 107, yes, that whole number is bigger than 10, is more than 10, but you realize that the individual figures inside 107 are all less than 10. The same applies to binary. Binary means base 2. And the base 2, we have numbers that are in a set 0 and 1, because there are only two numbers that are less than the figure 2. So when we have figures like 101, 100, 110, or 111, 01, 0110, the individual numbers in these figures are less than 2. That's why we term them as base 2. It is not the entire figure, which is 101, or the entire figure 100,110. No, but we are dealing with the individual figures 1, 0, and 1. They are both less than the number 2. So that's why we have binary to be 1 and 0. And in computing, we call them binary digits. And these binary digits represents on and off in a computer electronic circuit, the electronic circuit board, because this board reads electrical signals and electronic signals in off and on, and the on represents 1 and the off represents 0. So if I have 1, 0, 1, then I'll have on, off, on. So in converting decimal numbers to binary, I have a simple rule I call the remainder trick, which means I'll draw my table of 3 columns with 2 rows. On top of the top row, I'll have the first column representing my resultant base. That is when I'm converting the number n to base in a different base to base m. Then m becomes my resultant base. I'll put it in the first column. N, the number I am converting, will be in my middle column. And a, which is my remainder, when I divide n by m, what I will get as a remainder, it could be 0, it could be 1. And that becomes my remainder. And I'll put that column, I'll name that column remainder column. So if I have a number like, I have an example like convert 9 to base 2 or binary. Base 2 means binary. I simply use my rule. Let's see what happens. So I have my 3 column figure table with my resultant base 2 to be here, my given number 9, which is in decimal, to be here, then my remainder to be here, are represented by R, the first initial. That is my choice. You can use any other letter. Then I'll now ask and answer these questions. How many times can 9 divide by 2? I'll get 4, and my remainder will be what? 1. How many times can 4 divide by 2? I will get 2, and my remainder will be 0. How many times can 2 divide by 2? I will get 1, and my remainder will be 0. How many times can 1 divide by 2? I will get 0 and my remainder will be 1. So when I get this, immediately you get the 0 here. I will now start to count because 0 divided by now is 0. So if I get my result this way, I will now start counting from upwards, that is from down to up, and I will get my results as 9 base 10 will be equal to 1001 base 2. Let's take another example. Say example 2. Convert 47 base 10 or 47 in decimal to base 2 or to binary digits. So in converting this, I will get my solution to be, I still use the rule I like best, my remainder rule. My 2 will be here, my 47 will be here, and my remainder will be here. So I'll ask myself, how many times can 2 go into 47? My answer will be 23, remainder 1. How many times can 2 go into 23? My answer will be 11, remainder 1. How many times can 2 go into 11? I will get 5, remainder 1. How many times can 2 go into 5? I will get 2, remainder 1. How many times can 2 go into itself? That is 2. I will get 1, remainder 0. How many times can 2 go into 1? I will get 0, remainder 1. And counting upwards, I will get my 47 base 10 to be equal to 101 base 2. And this is how simple we can convert decimal numbers to binary. We'll look at the next video, which will be on converting the same decimal to binary with a different method.